Hello. Welcome to our session, DEV311, called Breaking Observability Chaos, Best Practices to Monitor AWS Cloud Native Apps. I'm John Joswiak, a solutions architect here at AWS. I work out of our Austin, Texas office. Been with AWS for just over a year, working in the cloud space for about 5 years, and overall about 20 years of IT experience. And my co-presenter.
Hey, welcome everyone. That's pretty loud. Marcus, I'm a solutions architect based in Houston, Texas. Been with AWS for almost 2.5 years now. Previously to that, I was an AWS customer for 6 years, designing, deploying, monitoring solutions on AWS. So hopefully we can help you guys with some insights on how to get more observability out of your workloads on AWS. But before we move forward, I'd like to know like a little bit the skill set of the audience. If you don't mind, how many of you guys here are developers? Any infrastructure or SysOps guys? How about architects? Cool. So let's move forward. So what we're going to see on this session here, we're going to obviously kick off with some landscape and trends that we're seeing on the monitoring space. And then we're going to go present you guys with some best practices on how to achieve observability on your workloads on AWS. And what we decided to do this year, we built a demo application so we can not only tell you guys the best practices in theory, but show how to apply those in practice on a demo app. And by the way, the demo is going to be available on GitHub for you guys to download, clone, and try out on your own AWS account. So feel free to do that. So what we're seeing in the past few years, like it's a buzzword, I believe everyone in the room heard about, is like digital transformation. So companies from all sizes and all different industries, they're trying to bring more value to their customers through technology and digital transformation, right? So one of the trends that we're seeing, like how they're building or replatforming or transforming their workloads, they're trying to kind of break the monolith, going through an API-based solution, distributed architectures. And if we go and zoom in into the AWS workload specifically, we're seeing a lot of like customers leveraging the undifferentiated heavy lifting that we do for them so they can focus on business logic, containers, serverless, and by serverless, I don't mean only lambdas, but like any managed service that take out the undifferentiated heavy lifting from your team so you guys can focus on the business logic of your applications. So it's all about like having happier customers, bring more values to the customers. So our customers try to create agility, empower their teams, and invent and innovate so they can fail fast, they can bring more value to the customers. Because if they don't do, what we see is a lot of disruption in every market today because the technology that is available for any of you guys in big companies are also available for like kids on colleges or on high school developing with their own AWS accounts. So technology is a commodity today. So people are trying to leverage that to bring more value to their customers. In order to bring value to customers, we need to have observability. So you cannot improve and bring more value to the customers using a specific service or a workload running on AWS or elsewhere if you don't have visibility, if you don't have observability of the workloads. And in order to have observability of the workloads, you need to have those 4 main pillars here available for you and leverage them properly. So the 2 on the left, most of you guys are probably using, and if you're not, you're behind. And we're going to talk about this. Metrics and logs, very known. The industry is using that widely. The 2 on the left are a little bit overlooked, and when used in conjunction, they're very powerful. I'm talking about events and traces, right? So as I mentioned before, the sample application is available here on this URL. We have another slide by the end of the session with that URL again. We're going to go into the monitoring, on the monitoring topics here, but first we need to understand how the application works, and that's how John's going to explain to us.
Yeah, so our application is called Acme Bots. So it's a IoT-based application focused on, think of robots like drones or undersea pipe inspection or vacuums, for example. that type of application. And really, it's just here to showcase monitoring. So we're going to go through and demo the application quickly so you have a good context for monitoring. Yeah, as Marco said, the code is available here. So here's the overall architecture. So the first piece of it is the user interacting with the front end. The front end's a React-based website. It's a static website hosted in S3. Users connect to that with Cognito to log in and authenticate. And then the main purpose of the application is just to create and delete these bots. So we go through and create a bot. That triggers a lambda, which is using step functions to orchestrate the process. And there's three main things that are happening during that. The first thing that happens is we're provisioning on the back end with AWS IoT. After that, we store the S3 certs and keys in a bucket, and that's just for the application to interact with or the bot to interact with. And the third piece of that is Dynamo DB. We're using Dynamo DB to store metadata about the bots, such as battery life, whether it's connected or not, and we can query that quite easily. The other part of the app then, from the S3 bucket, we can actually list the things in the Dynamo DB. We can also use it to interact with the MQTT topics. And so I'll walk through this real quick to give you a little bit more perspective. So for our demos today, we've recorded the demos to not test the demo gods. And so if we play here, demo gods don't like the video either. All right. So if we play here, this is just in the UI creating the bots. So we're going through and creating 3 bots here, and then also searching them. So we'll clean that up. And that didn't pause properly, so I'm sorry. Let me just correct this real quick. Let's see. So we go right there and continue. No, not quite. All right, there we go. So we created the 3 bots, and what that's...
Demo
the
gods.
spacebar works on my laptop.
Demo gods.
I'm just trying to pause the video. And on my laptop, the spacebar pauses the video. All right. So here is the step function that we're executing. So basically, we created the bot, and that bot is executing this step function. And so this is showing the executions of those step functions. And what we have here is the input that we're passing in, which is just the bot name, as well as the output that's being presented. So that output is just the thing name, certificates, and policy information. And then this is just part of step functions. It's showing the individual steps in a visual workflow. So you can see the steps that are being executed, and all of them in this case are successful. And then moving on, this in IoT is just showing the 3 bots are things that have been provisioned within IoT. They're related certificates that have been provisioned, and then also the policies that are attached to them. And then moving over here, this is our S3 bucket. So we've got 3 different objects in the S3 bucket, just 1 for each of the bots we've provisioned. And then within Dynamo DB, this is our metadata store. So we're storing a thing name with battery life, certificate, and a few other components. Now, for our bots, we didn't have access to hardware bots. So we couldn't go out and provision hardware for this. So instead, we're using ECS, our Elastic Container Service. And that's giving us a very simple way to provision bots as Docker containers. In this case, we have a cluster provisioned. We're not using services or load balancing or anything like that because it doesn't make sense for this particular workload. It's just a simple abstraction to replace the hardware. So we've used Fargate. You can see our 3 tasks here running, bots 1, bots 2, and bots 3. And then just moving forward from that, this is a new feature called CloudWatch Logs Insights. It gives a very easy way to query and filter our logs. So our bots are particularly logging just their status, whether they're charging, whether they're out working or going to standby. So here we're showing the ability to filter by message. And our message is just going to be our bot name or our filters by bot name. So you can see us walk through and filter for bot 1 and get the status for that bot 2 as well. So the Logs Insights provides a very simple way to do filtering and querying. All right, and then moving on from there, we're going back into the UI. This is our static website. And just selecting a bot here, and we can subscribe. This is subscribing to an MQTT topic. It's a publish subscribe protocol. And by doing that, we can see the current status of the bot. So this streams the status of the bot. We can see it charging. You can see the battery in terms of how charged it is. And as it's working, it's draining the battery, and then changes back to charging to charge the battery. And you also have in the UI the ability to send a command. So here we have the option to send a command to the bot, in this case sending a standby command. And so when we send that, this is just an example of the command that's sent, and then the bot will send back an acknowledgement saying the status is OK. So that was just a quick walkthrough of the UI of the application. Now for running the bots, I mentioned already the bots are running on ECS as containers. That bot, when it's started up, interacts with the S3 bucket to get its IoT cert and key, and that's so it can authenticate with the AWS IoT service. After it gets that, it can subscribe to that topic like we showed in the user interface to get telemetry. The front end also, well, it subscribes to publish. The front end subscribes to pull or consume the telemetry. And again, we're using Cognito up front to actually authenticate. The telemetry data that it's sending in terms of its battery life is being published every 15 seconds to that topic, and then the user subscribes to view that. And then the command example we showed is the user subscribes to the topic and publishes a command. The bot is also subscribed to that topic, so it receives that command and processes it, and then it publishes back that acknowledgement. So the basic bot logic is it's starting at a 50% battery life. It charges until it gets to 100%, then goes out and works, and as it's working, the battery is drained. So the battery continues to drain and drain until it reaches a threshold of 15%, then goes back to its dock and charges again. And you also have an ability to put the bot into standby. In that case, it will just go to the dock, charge up, and then wait for further commands. So this shows the logic. Basically, there's a few areas where this could break down. Obviously, if it doesn't get back to the dock and doesn't charge appropriately while working, or if it's in standby, there's areas here that we would want to monitor. So I'll hand over to Marcos to talk through monitoring. Yeah.
Cool. So now that we know how Acme bots operate, so basically we have bots sending data every 15 seconds. So you need to know like how the battery of the bot, how long is it working for, how long is it charging. We now can look into how to monitor that. So if you look into like the AWS Observability portfolio or the monitoring services that we have today, we have the CloudWatch services and we have AWS Xray, right? CloudWatch, it's a very known service. Like we have logs, we have metrics, we have events, we have dashboards, we have alarms. And Xray allows you to see a service map of your application. So if you have like a microservices solution or a distributed application that calls several internal and external services, Xray gives you a nice service map of that on the fly. It's very useful for like new team members joining a project. If they want to know what services does this specific service I'm going to be working on talk to, just go live to the Xray service map dashboard, look it, and you can see latency, where you can improve that or not. We also have like distributed tracing, so you can see the breakdown of a service. How long is it taking to do operation A, B, C, and D, like kind of like a waterfall view of that. And that's extremely helpful if you want to improve services, so you can pinpoint exactly like where should I focus first to reduce latency, for example, right? So now that we understand how Acme bots operate, we're gonna talk about 4 main monitoring scenarios here. The first one is like for every workload, any workload, being that running on the cloud, on premises, you need to have operational insights, right? So the number one best practices we'd like to share with you guys is like align your metrics to your business needs. I'll give you an example. Like if you have like a an application that has a queuing and producers and consumers, it might not be enough to monitor that only by using, let's say, CPU utilization for those consumers or producers, because you might not want to over-provision, let's say, EC2 instances. You might want them running at 80%, 90%, but a good metric for you to keep an eye on might be the queue size. So you need to think carefully when you select what metrics to monitor, and every application is unique. So it's not enough to live and monitor your application with the default metrics that the services provide to you, such as like CPU utilization, network in, network out, disk I/O, whatever. You need to have custom metrics. You need to have custom. That's not optional. How can we do that on Acme bots?
Yeah, so with Acme bots, there's a few aspects. Obviously, the bot's battery life is a custom metric that we'd want to manage. Also, the bot's telemetry delay, so the delay in the time of IoT writing the metric and us actually logging that to CloudWatch. And the third one is just package size, so the size of the payload being delivered to IoT. Because if that's significantly lower or significantly higher, it may indicate an issue with the actual packet sent. So for implementing custom metrics, on the back end, on the IoT side, we have our bots publishing their status to AWS IoT. So that's published to a MQTT topic. And this is just an example of the data or the data format that's published. And then you have a connectivity rule that's reviewing or pulling that data from the topic and triggering custom action. So we use Lambda to send that custom action. And what that does is it executes a put metric data call. So the Lambda executes to pull the data out of that MQTT topic and publish it to CloudWatch. And you can see here an example of a dashboard of the battery life of the custom metric, just as the bot's battery life charges or gets used. You also see in the upper right-hand corner here the bot's name. So we created a custom namespace, Acme bots. The metrics we're gathering, battery life, telemetry delay, telemetry package size, and then dimension just being the bot name, so bot 1, bot 2, bot 3, et cetera. So I'll show a demo of this as well. Let's see. So here we're just in the UI, and we see the bot working, and we're unsubscribed from that topic. And the data is essentially lost. So with MQTT, you just have the current data point. You don't have any other data. So it's useful for our web UI to look at that, but to actually capture historical data, that's where CloudWatch and custom metrics comes in. So here we can subscribe back to that back to that bot's topic again. And you see the data again, the current state. And here we're going to just use an MQTT client. Well, I hope we'll use an MQTT client. There we go. So here we've subscribed again. Now we're going to pull up the MQTT topic. And this is just looking at or subscribing to that specific topic. So you can see the telemetry data here. So just the battery life, the status of the bot, the time that's being recorded. And these are the IoT rules. So this is a rule just saying with that query, just querying from that particular topic and invoking the Lambda based on that. So this is all on the IoT side at this time. And then this is our Lambda code. So in this code, essentially, we are taking and pulling for each telemetry data point. And we're going to create a couple custom metrics. The first one here we're creating is for battery life. So we're taking that parameters, basically pushing that parameter in. So we've got an array for parameters, and we're pushing that battery life code into that array. And then at the end, once we have all of our metrics, we'll write that to CloudWatch. So that's the first one. And then the second one is the telemetry delay metric. Now for this one, what we're doing is we're taking and recording the value, just using the current value of this run, and then comparing that against the last recorded at metric, which came from the actual IoT telemetry data. So that will give us the essentially the delay. And the third metric we have is just the packet size. Package size. And for that one, we're just doing a JSON size to pull the value of that telemetry event itself. And so once we have all three of these collected, then we're doing CloudWatch put metric data. and that's just the API call to actually post that custom metric. All right, so now in the user interface, this is a CloudWatch dashboard we've just zoomed in on. We can see we've got our battery life custom metric data. We can look at the data points within that dashboard to see the battery life for all 3 bots. Here we've got our custom backend, or our telemetry package size. So this is just showing that packet size. And you can see a couple of drops in that packet size where there may be issues that we should potentially investigate, but otherwise it stays pretty consistent in terms of operations. And the third custom metric that we have is the telemetry delay. And here this delay is in milliseconds, but really what we're looking at is the telemetry time from that lambda being triggered to having that metric published in CloudWatch is sitting anywhere between about 1 to 2 seconds, but typically under 2 seconds. So there's not a significant delay there, but it's obviously not exactly real time. All right, and I'll hand back to Marcos for takeaways.
Cool. So what we just see here is like if we see the takeaways of the first monitoring scenario, is like, again, align your metrics to your business needs. So in Acme Bot's case, they need to know the battery life over time to see if there's a bot that's misbehaving and not charging, and dead on the ground floor, like we need to replace that. They need to know the real-time delay. So they need to know how far behind real-time they are once they receive those metrics. And they need to see the package size, because you might have a misbehaving bot that is sending metrics more frequently than every 15 seconds, or huge package size. So you might want to see that in your operations, right? So whenever you're defining or designing your strategy for your monitoring, think about what are the metrics that will make sense to the business, and then you work backwards from that to create a custom metrics. As John mentioned, we call the put metric API to create custom metrics. There are some techniques that you can use so you don't introduce delays, because this is an HTTP call, and sometimes you have like a logic loop running in your applications that you don't want to introduce delays. So if you're interested into that, we can leverage like CloudWatch logs agent. So you just send UDP packages like fire and forget, so you can send that information not only from serverless services, such as we show like Lambda here, but you can do that from on-prem or from your EC2 workloads or containers workloads. This does not apply only for serverless. The other thing is like, as I just mentioned, CloudWatch agent. It supports statsd and collectd, so you can send UDP packages to that, fire and forget. It's going to be introducing like 1 or 2 milliseconds of delay, which is fine for most of your applications. And I have another demo on that, so reach out to us by the end of the session if you're interested. And last but not least important, once you deploy that application, we have a CloudFormation template. We're not only going to be deploying the backend for that and the front end, but we're also going to be deploying automatically all the monitoring resources needed for that application. So that's a best practices. That is dashboards, alarms, and widgets on those dashboards, and everything you might need, maybe like event rules to process events, everything that is needed to manage your application, we are delivering through an automated process. In our case, we're using CloudFormation. So that's one of the best practices that I always tell customers to do, because a lot of times they say, hey, we have CloudFormation, we have CI/CD, we have an automated process, and how do you monitor that? It's a manual process, it's not consistent, you might have new metrics with new versions of your application. So try to leverage that. CloudFormation supports virtually everything, like even with the new services, within like 1 or 2 weeks, we have support to those. So try to leverage that when you deploy your application as well. So now we're reaching our second scenario for monitoring, which is like detecting and handling errors, right? So whenever I talk about this, I always like to call out one of the statements of our CTO, Werner Vogels: everything fails all the time. So that means you need to design your workloads and plan ahead of time so you can be resilient to failures, right? So you need first to be aware of failures. You need to know when failures happen. You need to be able to detect them and notify the right audience whenever errors happens. And last but not least important, you need to automatically react to failures whenever it's possible. It's not 100% of the case that it's feasible to automatically react to failures, but whenever possible, try to close that loop of self-healing automation. So John's gonna show how we do that on Acme bots.
Yeah, so with Acme bots, I mean, the key thing, or key error scenario is, how do I detect the bot not charging properly? How do I ensure that if there's an error with the bot's charging, that we handle that? And so to do that, we're using scheduled events. So we have a scheduled event that's running every minute, that's running a lambda to search for low battery bots. And to do that, what it does is it first reaches out to Dynamo DB. So it queries Dynamo DB. We're collecting the bot battery life metadata there. And you see here it's pulling back 3 bots that have battery life below our 15% threshold. So once we do that, we're also then having it logged to CloudWatch logs. And there's not a need for doing that from a detection perspective, but this is really so that we can keep track of historical information and have some audit trail in terms of our bots, in terms of whether they've had battery life issues or not. So after logging that event, what we do is we try to heal it ourselves, right? So we send a message to the MQTT topic for that bot, telling it to go back to its base and charge immediately. So basically triggering the charge. In some cases, that could work. There may be cases in a real bot use environment where maybe the bot's stuck for some reason. Maybe it doesn't get back to the dock and goes to 0% battery life. In our case, using Docker containers, obviously 0% battery life isn't important. But in a real life workload, at that time, you may not be able to self-heal that. And so for that, we want to make certain we send an alarm as well. So for the alarm piece, we collect a metric called low battery count and use that metric to trigger our alarm. So we have a CloudWatch alarm. And that alarm can then trigger a message to SNS, our simple notification service, and that will send an email notification indicating that there's a problem and somebody needs to go investigate. So we'll show that in action. So here we have the bots behaving as normal. The battery life is all working as expected. And what we're going to do here is we're just going to introduce a problem. So we are going to send a command to one of the bots, basically telling it not to auto charge. So in this case, we've got bot 2. We've sent the message, and we've seen the acknowledgement that the bot has essentially disabled its auto charging function. Sorry about that. All right, and then this is just showing in CloudWatch the rule that we have set up. And so this rule is just triggering a lambda. This is our scheduled event that's running once a minute. And then we'll walk through the code for our search low battery for our bots. So here in the first section here, the first thing that we're doing is querying Dynamo DB. And this is just doing a listing of all the bots that have a low battery life. So once we have that, we mentioned that we're saving that as a custom metric so that we can alarm on it. So this next section of code here is just doing a put metric data. So that is calling and logging that custom metric. And this is our self-healing section. So after we've logged that metric, we want to try to heal the bot if we can. So this is going to send a command to the MQTT topic for that bot to go back into its base and charge. And so there's the payload that indicates to start charging. And then just moving further down here, this section right here is just our audit trail. So this is our CloudWatch log that we're shipping, just to say, here's the devices that have a low battery. All right, and then moving on to our email. So you noticed we were sending an alarm and then emailing on that. Here's an example of that email. So it's just giving a name of the alarm, indicating that it's in alarm status. And you can see a number of alarms depending on the individual runs that we've executed. Now we move to our dashboard, and we've got a couple widgets here on the dashboard. One is just that low battery bot count. So that's indicating that one bot number 2, has crossed that threshold. And you can also see from a battery life perspective on the right widget the actual times where it hits the threshold or below the threshold. And then finally, we've added on a logging widget here. So this is a fairly new feature, being able to add your logs to your dashboard. So in this case, we can correlate our logs directly to our metrics. And so in this case, the log being bot 2 having a battery life that's reached 0. So now we're just going to look in MQTT. So this is our MQTT client, and we're just looking at those messages being sent for bot 2. So this is just the timing that it sent those messages to try to self-heal. So this is sending the message to start charging. And that's what's restarted the charging. And then you'll also see the acknowledgement message here, the status response with OK, indicating that the action's been taken. All right, and then the last thing we're going to do is just clean up. So we're going to go back and issue a command to enable auto charging again so that we don't run into this problem in this case. So now you'll see in the dashboard that our alarms have stopped. You'll see in the next dashboard section that also the battery charging has returned to normal. All right, and I'll hand back to Marcos for takeaways.
Right. So what we just saw here is like the whole error detecting and handling cycle. So we need to be able to measure, detect, notify, and fix errors in order to have observability, right? Actually, let me take it back. You need to have observability in order to be able to complete the whole cycle, measuring, detecting, notifying, and fixing errors, right? And how do we map that to AWS services? So the way we measure in this case was using like CloudWatch metrics. So we have the low battery bots count, which were basically a metric that we used to trigger an alert every time it was greater than 0. Then that metric used the alert trigger a notification to an SNS topic that call a lambda function. The SNS topic will notify the right audience. In our case, we send an email to an address that we subscribe to the topic. And then we finally close that loop by implementing a fixed auto-healing automation, which was basically, in our case, sending a command back to the bot running as a Fargate container saying, hey, go back to charge, right? So the key here is like being able to as you go in your journey for the error detecting and handling, usually you're gonna start with measure, detect, and notify, but try to go the extra mile to fix it automatically whenever it's possible. It's life-saving. Okay, so we saw 2 scenarios so far for monitoring. We saw custom metrics, we saw error handling, and now we're gonna see a third one, which is how to react to workload events, right? So whenever you have a workload, it might be generating events. So for example, we have events out of the box in some AWS services, for example, EC2. When you start an instance, you have a start EC2 event. When you stop an instance, you have that event. When you terminate, you have that event, right? But what a lot of people don't know is that you can have custom events into a workload. So we can generate events such as, hey, a bot connected, bot 1 connected, bot 3 disconnected. Or we can have a workload event say, hey, I received a notification, or I received a telemetry data. So it's very important to be able to have those events so you can stream that to external application in the case that they need. So John's gonna show how do we apply event streaming of custom events into your one workload, in this case, in Acme bots.
Yeah, so for Acme bots, there's a couple things that we would like in terms of events. One is just the status itself, whether it's charging, whether it's in standby. So that's one event, and then the other is whether the bot's connected or not. And so we'll walk through kind of how we would design that. Now, in our case, IoT is our backend. We don't necessarily want to share our IoT backend with everybody who might want to consume events. CloudWatch Events provides a good way to separate that. We can publish our event to CloudWatch, and then another application can consume that event. So in this case, on the left-hand side, we've got our bot publishing data in terms of connectivity or whether it's connected or not. And then based on that, we can use a connectivity rule that monitors that particular topic and triggers an event action. So that event action is a lambda. And what that lambda is going to do is it's going to call a put event API. So this is just calling a CloudWatch API to create an event. And you can see the detail of that event. And then you can create a CloudWatch rule based on that to say, monitor for these events and do an action. And that could be do an action if it's connected or disconnected, or it could just be always do an action. So in this case, what we're doing is we're using that event to trigger an update item and update our Dynamo DB table. And that table has the last seen time, as well as if it's connected or not, and the status. And this also creates a custom metric. So we want to track the event delay, so the delay in time between us having the event happen on the back end and having that event created and taken action on the front end. And the bot status is very similar. It's the exact same workflow, right? We've got the status being written to telemetry data in IoT. We use a rule to trigger an action based on that. And that action is doing the put event, basically creating another event within CloudWatch. And then us taking and monitoring that CloudWatch event queue and triggering custom action also to update our Dynamo DB table. So we'll see this in action. So first here we have our IoT rules. So this is just showing the query statement saying it's querying a particular topic and invoking a lambda based on that. And so this is our first lambda function. This function is what's going to write our CloudWatch event. So this is first taking for parameters, it's pulling in the connectivity status detail. And this is pulling that data from the IoT event. And then here we're using CloudWatch events to do the put event call. And that's just basically taking the event that we've seen in IoT and then publishing it. And then next up here, we're in CloudWatch and looking at the CloudWatch rule. So here we have our event pattern in CloudWatch that's just saying any CloudWatch event that's acmebots.connectivity will trigger this lambda function. And again, you can customize that event pattern to meet your needs, but here we're just doing everything. So you see the event source in the lambda, and then we'll dig into the lambda code here. So that's really irritating. There we go. So here in the lambda code, let me back up just a minute. Sorry about that. All right, so the first thing here that we're looking at is the event delay. So here we're calculating the delay based on the current time and the event timestamp. And then here we're updating the Dynamo DB table item itself. So this is updating the attributes for connected and last seen time. And that's basically the attributes that's pushing through. And then there's the update item call for Dynamo DB. And then finally, the custom metric that we're posting for the delay. All right, so then we go to our Dynamo DB table. And you can see our battery life in there. We also have the connected field, the last seen at time, the policy name. And so what we're going to do is we're going to go into our UCS cluster, and we're just going to stop one of our tasks to simulate this. So we go to our tasks, we select bot 2 here, and we're just going to stop that. And then if we go back to our Dynamo table, here in our Dynamo table, if we scroll over, we should refresh, and you can see bot 2 now, the status is updated to be not connected. And this is just the custom metric that we posted, which is a telemetry delay. You can see here we're on average sitting about 1.5 seconds delay for that, anywhere up to maybe 2.5 seconds. So very minimal delay. All right. So I'll hand it back to Marcos for takeaways.
Cool. So what did we just saw here? So we saw a couple of things. When we talk about events, you have two types of events. You have a schedule events. For those of you who don't know, it's a very powerful tool. Think about like a cron tab, cloud-based cron tab. So you can schedule, like you say, hey, every 15 seconds, every 15 minutes, every 5 seconds, whatever, execute an action. That's what we did to trigger a logic in the lambda function, right? So events enable automation. So think about like developers here, like when you're developing on frameworks that allow you to have like lifecycle hooks. Think about events you can introduce lifecycle hooks into your workloads running on AWS. For example, if you want to share, in the case of Acme bots, whenever a bot connected or disconnected, you just create a custom event that external applications can consume to execute automations on top of that. So the other thing is like when you have a bot below the threshold, anything that might make sense to your business, you can create those lifecycle hooks as CloudWatch events, custom events, that you can use to share the state of your workload or the state changes of your workload throughout your organization or even with your customers, right? The other thing that I'd like to call out, for those of you who don't know CloudTrail, so everything you do on AWS, being that through a CLI, through an SDK, or through the web UI, or AWS console, you're calling an API behind the scenes. And if you have CloudTrail enabled in your account, it's going to be logging all those informations. And you can connect that to events, so you can have events on services as well. So that's really powerful if you want to have like a custom events or events for your workloads based on some of the AWS services that do not provide CloudWatch events out of the box. You can kind of like generate those events out of CloudTrail. Custom support of events, so you call an API to create your own events. That's what we did on the demo, and it's available in the code for you guys. And all you need to do once you have your events or the events that you want to process, you just create CloudWatch event rules, and whenever there's a match, the payload of that event is going to be made available to a lambda function. That's a very common pattern, so you can trigger automations. And those automations can be done by consuming applications or services that don't necessarily use your service, but you might want to share those events or those state changes or lifecycle hooks into your applications with other consuming services. So the last monitoring scenario we're going to be showing here is troubleshooting. Whenever you're troubleshooting, you want to make sure that you have visibility of your workload. So how is are your services talking to each other? What is the service dependency? What is the latency on a specific service? And what is the dependency? Where can you improve that? Can you quickly identify degradation, anomalies, and so forth? So we have a service that is very powerful, especially when combined with all the other CloudWatch services. And we're going to talk about that, which is Xray. John's going to show you guys exactly how to use Xray into your workloads, specifically here on Acme bots.
Yeah, so for Acme bots, what Xray can do is first of all, it can map out my service dependencies. So when you've got a distributed application, it's very useful to be able to track all the dependencies in your given application. For example, if you're using a microservices or container-based application, that can really sprawl quite rapidly. So being able to have a nice service dependency map to walk through is very useful. And then also being able to track down bottlenecks and errors within that dependency track. So here I'm just going to give you a quick view of Xray, its service graph, and going through and looking at that trace. So here we're starting with our function, and particularly we're starting with our search low battery bots function. And if you click on the monitoring tab there within Lambda, you have this view. You can go click View Traces in Xray, and that will bring you right to the Xray user interface. So here in Xray, we're going to just switch over to service maps real quick. And here, what this will pull up is the map overall of your services. So you can see all the components that are involved in that. If you click on one of those functions, in this case, we're clicking on the search low battery bots here, you can see response distribution, just the timing of responses. we're going to scroll out to a larger view time, and it will recompute the map for that larger time. And so in this case, we're going to zoom in on one particular component here. So this is IoT things table. And you can see here the response times specific to that table. Now we can zoom in on the graph to see that a little bit more clearly. And you see there's a little yellow line there, or orange line. And if you click on that and bring that back up, you can look over on the right-hand side, and this will indicate that there's errors. So 2% of the responses are errors. So now we can dig into a trace itself and open up a trace. And what that gives us is a list of all the time spent for each individual stage for our application. So we can see in this case the response is at 2:02. We can see where we're spending time in each component. And we also have the raw data here that you can look at. Now with the raw data, you could also add stack traces from your application if you instrument it that way. So you could see that data right here within the Xray UI. So I will hand it back to Marcos.
Cool. So what we just saw here is how to use Xray to facilitate troubleshooting. So some of the takeaways that I'd like to give to you guys regarding troubleshooting on AWS is like, use AWS logs, first of all, to collect and centralize all your logs. Because you might be using serverless, so if you have an error in your Lambda function, that's going to be straight to CloudWatch, push it to CloudWatch logs. But like, what if you're using EC2, for example, or containers, and that container or that EC2 instance handled that request, there was an error, the log was there, but the auto-scaling group shrink that fleet, and you don't have that instance available anymore, so you can never check the log again. So it's super important to have log aggregation. You have your logs in a central location. And whenever you're using CloudWatch, please don't forget to set up a log retention strategy. By default, if you create a log group, I think the retention policy is like, keep those logs forever. But it's super easy to say, hey, for this log group, my retention policies keep it for 60 days. So everything that is older than that is going to be automatically deleted, so you're not overpaying for storage that you might not need on CloudWatch logs. Another very common pattern is like to pipeline the logs. So a lot of people keep the logs on CloudWatch logs, and eventually they transfer that to Elasticsearch and or S3, right? Because you might want to search previously before we have like CloudWatch logs inside. Customer complained that it was not that easy to search on CloudWatch logs. Hopefully now it's way better. It's a super nice product. But like, people might want to put that on Elasticsearch for whatever reason, share with other applications. So you keep it there. So you need to have a retention policy, not only on CloudWatch logs, but also on Elasticsearch and or S3. For instance, when the log reaches out S3, you might keep it for like 30 or 60 more days on S3 standard, and you might want to roll it out to a warm and a colder storage layer, such as like Glacier, for example. So you need to carefully think about it, because it's super easy to generate logs, and you're going to be overpaying for CloudWatch storage. On the Xray side, what we saw here, so again, Xray, the main benefit, service maps and tracing, right? So you can have a dynamic view of how your services communicate to each other, bottlenecks, error rates, and all that. But that's not only available for serverless. So it's super easy to integrate Xray with Lambda functions. But like, you can also use Xray on your containers, on your EC2 instances, or even on on-prem environments outside of AWS, because we have the Xray daemon. One of the screenshots on that video showed the payload is a JSON payload that you send to the daemon. UDP, fire and forget, so you do not introduce huge amounts of delays into your workloads. And you can have those informations running on the premises or known Lambda workloads easily integrated to Xray. So we saw those four monitoring scenarios here. And I would like to call out some best practices on monitoring as well. So again, I cannot stress this enough. You need to align your metrics to your business needs. So an easy translation is you need to have custom metrics, right? So whenever you're planning how you're going to be monitoring your workloads, I'll always make this suggestion. You can easily be lost in hundreds of metrics that you might want to monitor. For example, if you have a stack, you're gonna have let's say you have Dynamo DB, so you're gonna have all the metrics available from Dynamo DB. We're using lambda, step functions, and IoT. We have all those metrics available for them as well. But no, stop. First, you start thinking about what is important for you to monitor in that specific workload, and you work backwards from that, right? That always means you need custom metrics. So once you figure out what those metrics are, then you can implement them, right? It's always nice to have the whole stack metrics as well as a plus when you're troubleshooting or when you want to correlate or if you want to create different dashboards, like you might have an operational dashboard or you might have like an infrastructure dashboard or you might have a billing dashboard, how much you're paying for that workload across time. But it's very important to have your custom metrics, especially aligned to your business needs. Deliver your monitor resources as part of your application. So however you're deploying your applications today on AWS, hopefully automatically through CloudFormation, CI/CD, whatever, make sure you're also delivering dashboard, alarms, and everything needed to monitor that, right? A lot of customers tell me, hey, but that's a total different department on my company. We don't have this concept of whoever builds it monitors and handles support for that. But even on that case, it's still valuable for you to provide at least, let's say, a minimum dashboard. So you can say, hey, here are all the metrics that are available on my service. And you might say, hey, but why don't I provide just a documentation? Because I bet with you that if you just provide documentation, on the next release, you're going to have new metrics or you're going to remove previous metrics, and that documentation is not going to reflect those changes, right? So if you keep those dashboards or those monitoring resources on the CloudFormation template, it's code as part of your application. So as you change your application code, you change the code of those dashboards, which is basically a JSON payload on the CloudFormation template. And you can share that with whatever department is responsible for that, so they can have insights of what changed, what metric means what, kind of exactly what you guys do whenever you're using a new service. And you say, hey, what are the CloudWatch metrics provided by that service? We have a documentation. We keep that documentation updated, but I know that's a hassle, so I always suggest dynamically deliver those resources as part of your deployment process. Collect all four whenever possible. Metrics and logs are collected by most of the customers. A lot of them overlook events and traces. So events is super powerful. So again, lifecycle hooks available for external application or external departments or even customers to process and automate tasks based on changes on your workload. And traces is also super important, especially when you need to troubleshoot over pressure. Imagine trying to see that waterfall breakdown of bottlenecks with the logs. It's a mess. You cannot see that. Monitor everything, not only the whole stack of your application, not only the custom metrics of your application, but also services. The CloudWatch metrics of those services, limits, costs, API interactions, CloudTrail, triggering events, and all of that. So you need to think broader as well. Of course, customers always start with their own application, custom metrics, all the error detecting cycle, auto-healing automation. But once you have that and that streamlined into deployment process, and that's part of your DNA, I suggest you guys should kind of like zoom even outer and try to look at the big picture. Like, is the AWS service up and running? Is that a problem on my application, or is that an infrastructure problem? Is that a health problem that we're having on AWS? How are my limits? How far from the limits am I? And am I having a huge surge on peaks on my costs on lambda functions because I have like consumers triggering that crazy and I don't have like a throttling mechanism set up on that? All of that is important. Last but not least important, leverage other services that might allow you to enhance your observability. For example, if you're using Aurora as your relational database on your workload, Aurora has performance insights. So you might be able to see even more information on that part of your stack So I just gave some examples here, such as like Trusted Advisor, Macy, GuardDuty, CloudTrail, Config. But like, keep in mind that you might have more observability services depending on what your application is using. Please make sure to give us some review. If you think that John did a terrible job and I rock, tell us that. Just kidding, just give us 5 and we're all good. Thank you very much. We're gonna be hanging out outside. Again, this is the URL. I encourage you guys to test the demo on your own account. And thanks for coming. Enjoy the event.
Thank you.